I hope everybody can hear us. We are recording this. I'm going to turn it over to Alyssa, who's the Vice President of IAFSM. And thank you for joining today's presentation from Leica.
Thank you.
Yes, thank you, everybody. My name is Alyssa St. Clair. I'm the Vice President of IAFSM, and today we're going to be presenting on critical considerations in choosing a laser scanner. Mr. Ryan Roselli of Leica Geosystems has been nice enough to offer to present on this topic. Just a little background for Ryan. He has been working in forensic sciences for the last 17 years. He spent almost 16 of those years as a crime scene investigator using laser scanning technology as a tool in forensics since 2010. He currently lives in Kansas City, Missouri, where he worked the first half of his career with the Kansas City Police Department. During the latter half of his tenure as a crime scene investigator, he was a supervisor for the CSI section and the field forensics response for Johnson County Crime Lab in Kansas. Part of his duties included crime scene reconstruction, bloodstain pattern analysis, and shooting incident reconstruction. And Ryan is now a sales manager for Leica Geosystems, the public safety group for the U.S. and Canada, and he works directly with public safety accounts throughout the Midwest. So he has joined us today. Thank you so much, Ryan, for coming online with us. And I think that everybody can see your screen now. So I think, as Maureen noted before, we are going to be answering questions at the end. Most of you should see a questions tab in the webinar screen over on your right. So if you type into that screen, and we'll either answer your questions as we go or at the very end.
Awesome. Thank you so much for the fantastic intro. If I could, there is a little bit of feedback, I think, coming from one of the, I just heard, I don't know if that was on one of your speakers for one of the other organizers. It sounds like it's gone away, but thank you so much for the introduction. It's a great honor to be here. I'm very appreciative to the IAFSM for this opportunity, and I'm excited to talk to everybody that's online to join us. A few things just to get started. I do have some technical folks online and available to answer questions throughout the webinar. So if you are putting questions into the question panel, someone will answer them. If there are any technical issues, sound issues, anything like that while I'm presenting, I am not monitoring the actual webinar panel, so please let Alyssa know, and she'll notify me if you need to break in. Please feel free to if there's a technical issue we need to address on the fly. Does that sound good to you?
Sounds good to us.
Awesome. I love it. Let's get started. Our topic today is critical considerations for choosing a 3D laser scanner. There's a lot of options out there. There are some new developments in the field and new products. Alyssa did a great job introducing me, and I appreciate your kind words. You know, in the two laboratories that I've worked as a part of in their forensic science operation as a crime scene investigator, in both instances, we were accredited by ASCLD. In the latter laboratory, Johnson County, Kansas, we were accredited to the ISO standards. So I've been working in an environment where not only have we been deploying laser scanning, but we've also been studying the science of it pretty deeply, so that our methods, our procedures, and our validations are all sound as we have gone through that accreditation process, reaccreditation process, to make sure that things are what they need to be. At current, I'm also a member of the N.I.J. OSAC Subcommittee on Crime Scene Investigation and a member of the National Sheriff's Association Committee on Emerging Technology. So I'm very active in what's happening right now in crime scene investigation throughout the country, and I really am proud of that. And I like to take whatever feedback I can from anybody and bring it to those groups as far as information that is happening from our side coming out, or from agencies out there that want to provide feedback. The one thing I'll say about the NIST, N.I.J. OSAC subcommittees, on the webpage, on the NIST webpage on forensic sciences, there's typically an area where you can click on public comments for any of the different documents that have been issued. I would just recommend to anybody that's listening to this or that hears it later on in the archived form, visit that page and be aware of the documents that are out there for public comment. Those documents documents are going to shape the future of forensics and public safety response to crime scenes and forensic type response. So be a part of that discussion, join in, and I think that there will be great benefit for that. When we were first approached about doing a webinar for IAFSM, it was primarily designed to be about the BLK 360. You can see me holding it there endearingly, and there's a bigger shot of that, and I can't hide my enthusiasm for it. It's one of the coolest things that I've ever held in my hand. And towards the end of this presentation, we will get into the BLK 360 and talk about its capabilities, show you some data. But building up to that, it's basically going to be a discussion of the considerations that need to be made when considering a purchase of a 3D laser scanner, or looking at the scanner that you currently have and evaluating kind of where you sit as far as that scanner's ability to be used for different tasks in public safety response. I had the pleasure and honor of being a part of the research team that worked on this landmark report on 3D crime scene scanning devices. There was a wide range of scientific contacts, technical contacts, just to give a shout out to the RTI International and their Forensic Technology Center of Excellence, as well as a colleague of mine, Brian Wangler, a fellow crime scene responder and laser scanner. There were a lot of hours put into this study, and the goal was to provide an impartial resource for the forensic community to use for decisions concerning procurement, training, fielding, and use of 3D crime scene scanning devices. Now, this was the first time that there was ever a formal report issued discussing critical considerations, and in an ongoing manner, beginning back, I believe, in 2012, when N.I.J. began some work with Virginia Commonwealth University evaluating different devices for crime scene documentation. That was really when the ball got rolling on looking at these 3D devices and how they are used and can be implemented, and just a wide range of issues. So it was this was kind of the pinnacle of all of this work. 2012 through 2016 was the issuing of this report. There were 6 total vendors that were evaluated as a part of that report, and I'm going to pull from some of the information in that report. I'm not going to get into much vendor-specific information today, but rather just talk about some of the concepts that were discussed either in that report or pulling from some of the resources that were used to issue that report. Firstly, one of the sections of that report is a forensic surveying, a sample methodology, and some of the key terms in this sample methodology is respond to the scene with the appropriate 3D laser scanning equipment. Well, we are talking about forensic surveying here. Surveying in general is a technique of and science of determining 3-dimensional points, the distances and angles between them. So right out of the gate in the sample methodology, we're talking about and referring to a scientific technique, and I think that that's an important thing to realize. Error and accuracy are critical aspects in verifying that the scanner selected for purchase has the capabilities to produce survey-grade measurements. And again, in this report, as you read it, it was actually designed in part as something of a buyer's guide. So where it says here, verifying the scanner selected for purchase has these capabilities, that was the goal, was to be able to help present to anybody reading this the landscape of devices that were available in that snapshot in time back when we released this in January of 2016. Survey grade measurements using sound methodology that will stand up against Aubert or Fry hearings in court proceedings. These are very, very important aspects of what we are doing as we deploy equipment into the field for scene capture, for crime scenes and forensic purposes. We have to make sure that we're going to stand up to those challenges when we get to court. Some of the documents that were used to as sources of information for the N.I.J. study included reports delivered at the Forensic Science Error Management International Symposium in Washington, D.C. in 2015. Specifically, there were 2 reports of note, one by Dr. Megan Schilling from NIST on 3D scanner error sources, and then one by Dr. Gregory Walsh. Dr. Walsh is the architect of the scan station with Leica, and he presented on measurement errors with point clouds. Firstly, looking at Dr. Walsh's presentation and kind of talking about some of the things that he got into, his information kind of differentiated between a laser scanner or an imaging scanner, a 3D camera which uses a scanning laser beam that can create point clouds and create images. Basically a tool for creating demonstrative captures of a crime scene or any scene, any site. I will refer in many instances, I'll say crime scene, I'll say in forensics, but of course the instruments we're talking about can be applied in any of the areas, any of the segments that 3D scanners and surveying is often deployed. And then there's survey grade laser scanners, scientifically matched to survey market requirements. So this means we have survey grade error rates and then environmental durability for collection of scientifically valid data. If the instrument being used isn't going to collect valid data given the environment that it's working in, well then it's not going to meet the need of somebody that needs a survey grade laser scanner. One of the ways that laser scanners and their tech specs are created is by being placed on a fixed base. This is one of the things that we need to be careful of because fixed base scanner measurements don't account for all field conditions. When we're thinking about laser scanning, we need to be aware of how they're going to perform in the field and realize that there are two categories of laser scanners, imaging scanners and survey grade laser scanners. You know, basically breaking it down side by side, an imaging scanner is appropriate for 3D documentation. It will create an image, it will create a 3D image, a 3D point cloud that can be used for demonstrating a crime scene or, again, any site. Survey grade is appropriate for both 3D documentation and forensic surveying and reconstructions. Basically analysis. If somebody is going to be using a point cloud to obtain measurements from which an analysis will be performed, that survey grade aspect is very critical. Again, appropriate for demonstrative evidence, and then survey grade is appropriate for both demonstrative and scientific evidence. With an imaging scanner, there's an unknown error rate due to unknown accuracy of key components of the scanner. And with the survey grade, there is a known error rate due to known accuracy of all of those components. And ultimately, an imaging scanner is not a scientific instrument, whereas a survey grade scanner is a scientific instrument. So the requirements to evaluate whether or not you know, something is survey grade, first and foremost, there have to be three known components: known range, known horizontal angle accuracy, and known vertical angle accuracy. Not only do we have to know these to establish you know, whether the initial specs are survey grade, but is the design and construction of the instrument sufficient to hold a calibration? Is a calibration process designed to allow accuracy to be maintained throughout a full specified temperature range? These are things that we have to be aware of, because if you have something that's survey grade at 60 degrees, but at 0 degrees, at 120 degrees, you may have some fallout outside of that that accuracy range. There's issues that need to be evaluated. We have seen scanners that will operate in cold weather, operate in rain, some cases very, very torrential rain. And when we're doing that, when we're capturing in those scenarios, and you can see downrange this twin target pole, that's a 1 meter from point to point. That's a quality measurement that's placed in the scene. We have to be able to evaluate whether the data that we're working with is sound. Having quality methods in place, being able to check those very quickly in the field, for example, with this the twin target pole, and methods like that other vendors other than Leica, this is of course the Leica twin target pole that other vendors deploy. I think that's a very critical aspect, being able to do that, to place a known artifact, a NIST calibrated artifact into your scene, and to verify that. So that is something that we definitely have fall into that critical aspect. Generally, you want to evaluate laser scanners, you want to take it to the field, because the specs on a laser scanner are just that. They're tech specs. And again, you know, something may have a stated range, and then the actual capture for a scanner may not be as robust as the range stated by the spec sheet. Now, in one instance, that's likely because of how scanners see. Now, laser scanners see by measuring albedo reflectance from the objects that the laser is striking, and the closer to black, which is 0% in the reflectance scale, something is, the less likely it's to reflect and get a measurement from the laser. And the closer to 100% or closer to white or something like a prismatic surface, the more likely it's going to give a return and be able to be read by the laser. So in instances in which, you know, you're evaluating laser scanners, you want to take your scanner out to the field. What are you seeing? Scan to the vendor's targets, inspect the data in 3D. All of these things are very important aspects when you're trying to decide what scanner is right for you. Put the scanner into the situations that you'll be using it in. You know, just having it scan an office conference room is really, unless you scan office conference rooms on a day-to-day basis, that's not testing the thresholds of the types of things that we see at traditional crime and crash scenes or in the forensic uses that we're putting these scanners into. Currently, there are no standards facilitating the apples-to-apples comparison of laser scanners. There's no consistency across tech specs that are offered by all of the manufacturers. Typically, manufacturers will either borrow terminology from total stations that are used for surveying to express scanner accuracy, or they don't provide data related to scanner accuracy, or they publish information about precision rather than accuracy. And I think that that's a really you know, critical component that we need to look at is what is the information that's being put out. Now, for survey grade total stations, there are three pieces of information that are typically published for survey grade total stations, and that's range accuracy, horizontal angle accuracy, and vertical angle accuracy. And if we look at the laser scanner error sources presentation made by Dr. Schilling from NIST at the Error Management Symposium in 2015, there was basically three components to any measurement system that she referenced, and she actually took a page out of the Leica playbook as she was referring to these three systems. This is a cutaway of one of our scan stations that she used in her presentation, referring to the three different measuring systems: the vertical angle measuring system, the distance measuring system, and the horizontal angle measuring system. And with those three measuring systems, you end up with three separate measurements that are combined for the X, Y, and Z coordinates, or a 3D position. Basically, that's a point, that's a coordinate, it's a northing and easting and an elevation, or an X, Y, and Z. You might hear it referred to in all of those different ways. So who cares about the accuracy of scan data? Well, it's coming to light in court on a more frequent basis. This was the very unfortunate case that occurred in South Carolina, in which a police officer shot a person. The case had gone to court. This is a shot from that case, and this goes to court, and this is now being reported by the news that the aspects of measurements are being questioned in court, and it's being reported. Error is being discussed, and reporters are bringing this into the media. And what the media reports and what happens in the courtroom are typically two different things, but it's getting public acknowledgement, the types of things that we're concerned about. Are there error in the measurements? What's being used to obtain those measurements? So who else cares about the accuracy of my scan data? Well, again, attorneys. This guy, and if you're not familiar with who this guy is, he was on the dream team that defended O.J. Simpson, and he is one of the co-founders of the Innocence Project. This is Barry Scheck. So, you know, attorneys are definitely on that list of people we want to be thinking about as we're moving forward and being concerned about accuracy. From my world, having come from the accredited laboratory world, laboratory auditors are definitely concerned with accuracy. Crime labs are moving in a direction when uncertainty of measurement is a very great concern. At present, most labs typically look at barrel lengths of guns and drug weights, as well as potentially some aspects of toxicology as their measurements that are critical or defined as critical, so they're applied that uncertainty of measurement rule. But it's everything is moving in a direction where who's to say in 5 years how that list of critical measurements may look, and do we have the ability with the scanner that we're using to do an uncertainty of error budget and calculate the uncertainty of error for that instrument. It was one of those kind of words, or one of those phrases, uncertainty of measurement, that every time it came up we'd all cringe because we knew that there was going to be a lot of data recording and math involved with tracking whatever the information that somebody needed to know was. And it can be very rigorous studying an instrument of any kind for uncertainty of measurement. So who else should care? Well, all of us, anybody that's using a laser scanner. Our cases are on the line. We're sitting in the hot seat. We're testifying to the data that we're collecting in court. Our agencies, our labs, our accreditation may be on the line, and our reputation. If we are testifying to information that we cannot back up, that is something to be of concern. And it's, coming back around to this, we're talking about the difference between an imaging scanner and a survey grade laser scanner. So, at the end of the day, if demonstrative evidence is the goal, well, an imaging scanner is certainly going to meet the need. But if you're making measurements that are being used in analysis and reconstruction, that's where we're saying, that is a critical concern. There is a whole list of stakeholders in 3D laser scanner equipment selection that may ultimately have something to say about the data that we're using, and it's just a really thorough consideration that we need to make about all the people that may be affected by both what we're using as tools today and what we purchase as new tools for our tool belt tomorrow. So when we have answers about accuracy and measurement uncertainty and admissibility of scientific evidence, there is a wide range of folks that are standing there waiting to hear what we have to say. Certainly if we were moving forward with a blood alcohol tester, we wouldn't go forward with an instrument with unknown accuracy. We would definitely be mindful of that. And anytime we're talking about aspects of data collection that can be used when somebody is on trial literally for their life, we need to be aware of what we have as far as error, accuracy, and as you can see here, they make mention of precision and accuracy, which is a comment worth noting. The landscape study on 3D crime scene scanning devices included a glossary of commonly used words and phrases. There were 2 documents that were used to call this glossary. One was the ASTM document on three-dimensional imaging systems, and the other was the International Bureau of Weights and Measures vocabulary of metrology. This was included, or this was included in the N.I.J report. This is a section of the ASTM document on 3D imaging systems, and it is a critical aspect to be aware of. It is specifically stated in this document that the term precision should not be used for accuracy. We're fortunate to have organizations like IAFSM that are focused on measurement sciences, so documents like this are held in the appropriate light, and we have groups studying this and doing research and encouraging research in this area so that we know the information that we need to know to be successful moving forward. So what's the difference between accuracy and precision? Well, accuracy is basically, are you achieving the correct result? With precision, you're achieving a consistent result. It isn't necessarily the correct one. And with both accuracy and precision, you're consistently achieving the correct result. They are not synonymous, but they often are in common conversation, and it is something to be aware of, that there is a difference between the two. Range specifications exist out there that don't mean accuracy. Range error does not equal range accuracy, and range noise does not equal range accuracy. Those are measurements that can be obtained, but they're typically referring to systematic error demonstration across the use of an instrument. So they're very, very much not equal to stating the accuracy of any particular instrument. Survey grade scanners will always specify what the range accuracy is. If it's any other term other than accuracy, it's probably not accuracy. The horizontal angle accuracy as well as the vertical angle accuracy. Those three components together, as I referenced in Dr. Schilling's discussion of sources of error measurement in 3D scanners. So again, we've got two buckets that laser scanners are falling into: imaging scanners and survey grade scanners. And again, the imaging scanners are very appropriate for 3D scene documentation. They may not be as appropriate for, or they are not appropriate for documentation for reconstructive situations. They're appropriate for demonstrative evidence. They have unknown error rate, and they're not a scientific instrument, versus the survey grade, which are appropriate for both demonstrative and scientific, and are scientific instruments. With survey grade laser scanners, as you're evaluating the system that you're using or you want to use, you should be concerned if your data is altered from the manner in which it was collected in the field when it's brought into the point cloud software. Speaking in forensics, when we take an image, we don't want that image to be altered from the time we take it to when we upload it into our long-term storage database. We don't want points to be moved. We don't want pixels to be rearranged. We want to have a permanent impression of that scene. So that is one area to be aware of, to look at. Your scanner moves during the scan and you're not alerted, you should be concerned. If there's a seam at the start or end point of your scan, you should be concerned. If there's no mention of these horizontal, vertical angle accuracy in the tech specs on the laser scanner, you should be concerned. And the accuracy varies depending on the environmental conditions. You may not have a survey grade device. And then finally, if your scanner requires on-site calibration, that's an area to be concerned. I mean, being able to complete an on-site calibration is a valuable aspect if the scanner is falling out of calibration in between scenes or with a more routine, on a more routine basis. So again, as I mentioned earlier in the presentation, a scanner's ability to hold that calibration is something that should be thought about when you're looking at what equipment is right for you. Error and accuracy are critical aspects in verifying a scanner selected for purchase has the capabilities to produce survey grade measurements using sound methodology that will stand up against Daubert or Fry hearings in court proceedings. And let me mention, we used Daubert or Fry. There are different state level court admissibility, names for admissibility hearings. Basically what we're talking about here is court admissibility. Will the instrument be able to stand up in an admissibility hearing? When we look at one of the prongs of Daubert, we look at the 5 prongs of Daubert, which are listed here. One of them is general acceptance. And typically we're referring to general acceptance within the relevant scientific field. Who is the relative scientific community for laser scanning? Well, one of them is going to be surveyors. These are the base group. This is the base group that is collecting survey data. There is an American Congress on Survey and Mapping. It's defining survey as a science and art of making essential measurements to determine a relative position of points, etc. And I mentioned this earlier. So surveyors may be the relevant scientific community. These are folks that may show up in court to contest what you are presenting as far as evidence goes. And there are instances in which the technical aspect of the data that you've collected may exceed the person who collected its capability to discuss it, and it does get elevated to the point of expert versus expert in 3-dimensional data, and that does definitely happen. When that does happen and we have these 5 prongs of Daubert, what we can end up seeing is something like we had in 2011 with our Daubert hearing referring to the Leica scan station, the use of the scan station in a criminal case, as well as the presentation of that data in court, the use of our Cyclone software and the MapScene software. The witness list for this particular presentation was Detective Keith Johnson, who was a scan station user, scientist Mike Haig, also a user, and then Dr. Greg Walsh, system architect of the scan station, and Tony Grissom, a subject matter expert on the scan station for forensics. In this particular instance, those experts were available in the case that it elevated above the ability of Detective Johnson or forensic scientist Haig to discuss the aspects of the scanner. In this particular instance, we did successfully move the scan station, the data, and the software through that process. But one of the false narratives that has grown from this is that the Albuquerque-Daubert ruling was on laser scanning technology in general and not any particular brand of scanner. So folks are saying, well, it covers our scanners also. Well, these were scan station users. It was a scan station that was presented in court. The motion and the transcript was to affirmatively admit Leica scan station evidence. And there was both a state level and a federal level, and at both the state level and the federal level, the federal level being the Daubert challenge, there was a motion to affirmatively admit Leica scan station evidence and related expert testimony in this case. So this Daubert ruling, this court case in which our scanner, our software was admissible, was related specifically to Leica. And it's important to note that because just because this was successfully entered into court in 2011 does not mean that every instrument that is out there may pass that admissibility hearing. And again, you can see here the Leica scan station evidence passing the Daubert. So again, it wasn't broadly covering laser scanning technology. This is not accurate in many cases as it's being discussed. Several years ago, there was a YouTube video published in which some kids hacked an Xbox Connect and figured out how to do 3D laser scanning with it. So if we're going to say that all laser scanning is considered valid for admissibility in court, well then, you know, a 3D Xbox, an Xbox Connect can, you know, head out to your next crime scene and capture data, and you can use that for your scientific analysis. It's just not a valid way to approach our data capture to think that anything will capture measurements appropriately. So it is something to be aware of. So, you know, that's kind of talking directly to some of the aspects of survey grade instruments, and I want to shift over to the BLK as I promised I would. The BLK is our imaging scanner, and if you can't tell that I'm excited about it, and I have a wide range of photos, I guess, you know, maybe it's just so small and so sleek, and I'm enjoying the opportunity to both work with it directly and work with the data. But I love where we're going right now. When I first saw it, I got very excited. I've been in 3D measurement sciences for many years. I've been a laser scanner since 2010, and to have something so very small was quite amazing. Now you should know that I'm 6'6" and 300 plus pounds. I'll leave the actual number off the plus, but so you know, I am a fairly big guy. So that BLK though, it's 6 inches, 6.5 inches by 4 inches. It weighs 2.2 pounds. So even though I'm a big guy, it still is nearly as small as it looks. And some of the specs on the BLK 360 imaging scanner, it captures 360,000 points per second. It does a full dome scan plus image in under 3 minutes. It has range to 60 meters. It has ranging accuracy at 4 millimeters, at 10 meters, and 7 millimeters at 20 meters. And it is rated to IP54, but with an exposed mirror. So if we swing back to the discussion of weather durability from earlier in the presentation, where we had our twin target pull down range and we were capturing information, that mirror was enclosed. The data coming off the instrument in that instance was fine. There was atmospheric noise, absolutely positively. Our mixed pixel filtration and our waveform digitizer, you know, two algorithms that help keep our data looking sharp, filter out some of the weather components, but in a downpour like you saw there, you're going to see some noise. And that's all it is noise in the scan, but the measurements being taken are fantastic, and it's a completely valid scan, and the twin target pull was verifying that downrange. The BLK 360 being rated to IP54 with an exposed mirror, well, IP stands for ingress protection, and 54 is a dual numerical rating. The first number indicating something's durability against dust, and the second number against moisture. And basically what this means is the BLK can be rained on. But with that exposed mirror, collecting data in the rain becomes quite a bit more problematic, and there would be some questions as to the validity of that data capturing information in the rain with that exposed mirror. Some of the key assets, ease of use. If you've seen any photos or any demonstrations of the BLK, there's literally a single button on it. You press that button to power it on. Once there is a green ring around the base, you press it again and it engages a 360-degree full dome imaging scan of the site. You can also control the BLK 360 via the iPad Pro with the Recap 360 Pro app from Autodesk. Our release of the BLK 360 has been in a partnership with Autodesk, and you can see the iPad Pro with the Recap app open there. And that image is to scale, showing the BLK against the iPad Pro. Cloud connectivity, you can collaborate with Cloud Sync. You can actually be capturing data in real time. It's registering in real time automatically on the Recap app, and it can be funneled up into the cloud, so you can be sharing information with folks at the office or wherever you need. I know in public safety, the cloud connectivity is something that we're kind of still riding a little suspiciously on, but we may see that turn a corner at some point in the future, especially as internet security protocols get a little better. However, in an era where apparently anybody's email can be read by anybody else at any time, maybe that will never happen. I think time will tell with that. Portable. It is 6.5 inches by 4 inches by 2.2 pounds. Again, I mentioned I'm 6'5" and a fairly large fella. That means my clothing is big. This thing is small enough that I can fit it in my pants pocket. It's pretty impressive. And finally here, one of the key assets is flexibility. You can set it virtually anywhere, and it's able to achieve fantastic data collection from any location. Some of the other key features, there are 3 cameras along the side. I think most folks with their scanners, and again, I can't speak to all makes and models and devices and how everything's configured, but especially for myself using Leica scanners historically, if you were able to see the lens, you were potentially being photographed. Well, it's different with the BLK 360 because the cameras are on the side as opposed to being deployed from the same mirror and housing as the laser. It is capturing high dynamic range images. Each sensor is 5 megapixels. It collects 10 sets of 3 images, resulting in 150 megapixel full dome image. There is an LED flash at each of the cameras, so there is flash support to provide additional illumination at each of those camera locations. And there's a forward-looking infrared camera, or a FLIR camera. This is providing a thermal panoramic image, and I believe it's 360 degrees by 70 degrees in the field of view, where it's actually reading thermal information or heat information of your scene, and you're able to map that heat information directly over top of the point cloud data that was captured. We spent some time working with the BLK, our public safety group. This is some of our public safety team, and we set up a mock scene, and we went out and scanned it and did all kinds of neat things and set it by itself. That photo you saw of it sitting on the ground under the vehicle was from this shoot. Here we have the tripod, which is such a cool form factor in the tripod, and if you haven't seen, there's a couple different demo videos that I've done personally that are available online, and if you shoot me an email, I'll be happy to get you the link to those. But you can see how this tripod folds down into such a unique, compact little package. Everything about the BLK makes it, very easy to just pack away in a backpack or a carry-on. Really quite fantastic. In this instance here, you can see that it's inverted, and it absolutely will collect data inverted. There's an IMU within the BLK that will track the movement of the scanner from position to position. So that's going to be a huge component in assisting with the registration process, both as it goes into Recap or if it's worked within Cyclone software. So out at this particular site, and you may have seen some of this data already, this was a fly-through animation, which fly-through, when we use that term as it refers to what we can create within our Cyclone software, we're referring to a dynamic view of static information. So what you're looking at is actually static information. And what I'm going to say is that I know for a fact that animations don't play well over webinars. So if anybody wants to see these otherwise, I think I'll be able to get them posted on YouTube and provide a link if anybody was interested. But this was the data exactly as it came off the instrument. I believe we did 8 scans out there, 8 different positions. Again, one of the things we're considering is the fact that, the scanner scans out to 60 meters, but if you look out into the distance, there's not as much information as there is at close range to the scanner. So again, effective range of any device that you're considering has to be considered. The folks that you see standing around, that's members of our public safety team as we were working with the instrument. Now, myself personally, I do think it looks cool to have us kind of standing around and we're having little conferences as each of the scan positions. And again, I don't know if I mentioned it, but 3 minutes full dome scan, scans plus image with the BLK from each position. So we'd hit go and then basically stand there and have a conversation, take some pictures, and then move it and hit go again. And really easy. Didn't have the iPad Pro pushing it. We're basically just hitting go. And when you turn it on and you get that green ring and you hit go, it does a scan. Once the ring is green again, you essentially can pick it up and move to the next position. But so this was the video of the data coming straight from the instrument, but I went in and cleaned it up because, typically at crime scenes I've worked, I've tried to keep them fairly clear of personnel. So I wanted to give a view of what it may have looked like if we were able to have kept the cars from driving through that were kind of interlopers or all of us standing around. So this is a cleaned up version of that data presented from the BLK 360. And both the previous video as well as this video were collected from beta instruments. This was not the operational deliverable that will be shipped. This was a beta instrument that we were working with in training to be prepared for this tool coming into our tool set. So just keep that in mind, please, and the final results will likely vary slightly from this and most likely in a positive way, whatever changes are made as things move forward. Best case scenario, in my opinion, is to have both a survey grade laser scanner and an imaging scanner. I worked a double homicide in 2014. The primary area of the crime scene was in the basement of a house. The suspect had traveled through and so this is a 3-level house. The suspect had traveled through primarily the basement and the ground floor. There was some evidence that he may had gone upstairs as well. So we scanned the entire house. At the time I was using the ScanStation C10, and using the ScanStation C10 versus the BLK is a completely different user experience because the BLK allows for a much more quick, a much faster tactical scan data collection. But the areas in which I was concerned with analysis, the basement where there were bloodstains and shooting aspects that needed to be reconstructed, those areas would have been appropriate for the C10 as captured. But if I had had a BLK at that time, again, this was several years ago, I would have deployed it through the rest of the house to capture demonstrative evidence from the rest of that house. There is a concept being discussed and kind of a buzzword that's out there called swarm scanning. You can have as many BLKs as you can deploy in the field, capturing data simultaneously, and the data will be streaming in to the Recap 360 Pro in real time. So with multiple instruments out there, you can be capturing and reconstructing data very, very quickly. And again, one of them, in many instances, folks would be like, well, what do you mean you have several BLKs? I mean, I need, more than one scanner. Well, one of the, major attractive aspects of the BLK 360 has also been the price. It's something that we've had out there. The scanner is $15,990 US dollars. So, the concept of buying more than one instrument, it could be a reality for survey grade scanners for some agencies, but it's bringing that reality to basically anybody. And the BLK is kind of democratizing laser scanning, bringing it down to an available and attainable range in both capabilities as well as price for anybody that might be interested. The concept of swarm scanning, I think, is a really valuable one, and really if it was one survey grade and one BLK, to have the two of them moving through a crime scene tactically, I think is a really neat concept, one that I'm excited to see deployed in law enforcement and public safety in the U.S. in the year to come and the years to come. So summarizing, we talked about the landmark N.I.J report describing key considerations for scanner purchases and best practices. Identified that there are two different types of laser scanners, and knowing the difference between the two is a key procurement decision. The report is clear on the need for survey grade measurements for surviving Daubert or Fry hearings, and that imaging scanners can provide visually stunning results, as we saw, if that meets your need. And that's really what all of this comes down to, is that all of these are considerations. And again, other than talking about the BLK 360, which was a part of the original and very specific request, I tried to remain as just kind of agnostic as possible and just talk about concepts. Really, these concepts are the things to be considering and should be the factors that you look at as you're moving forward with a purchase, or looking at what you're using now to figure out if it's meeting the need for your crime scene, your public safety, your forensic scanning scenarios. So these are the folks that we have to answer to on a case-by-case basis. We want to know, is what we're using admissible as scientific evidence? And I think it's just that, all of this in total can shape how we move into the future. So I am open for questions, and I greatly appreciate the opportunity to present that information, and I'm happy to answer questions now.
Thank you, Ryan. That was really wonderful. I would love to see the BLK demonstrated at some point in time. So you say that the beta version is what you're working with right now. When do you anticipate the BLK being available for
any information? Well, firstly, you can go to autodesk.blk360.com, I believe is the website. I'm just kind of reciting that from memory. And number one, you can purchase it at this point as far as reserving your place in the distribution line. But that website and the communication channels on that website are going to contain all of the information about relevant dates, distribution, and shipping. Certainly I'm a small cog in a bigger machine when it comes to things like that. We do have a BLK team that's working on things like that. For anybody that's listening, and we're, headed towards our Hexagon Live conference, I think it would be, if you're interested in learning more about the BLK and you want to see things in person, I can promise you that there will be units there. And we had it available at SPAR for people to use and demonstrate, SPAR 2017 in Houston, which was the first week of April. Basically at this point, the people that are going to have it first, we had a golden ticket promotion where you could buy a ticket and get in line for the BLK, and those are going to ship out. But again, if you want to see it before you buy it at this point, we'll be setting up road shows. The scanner will be deploying. We'll have a dealer network that will have BLK 360s. There's going to be a wide variety of ways to actually put your eyes on one, and that schedule of deployment really is going to be discussed most relevantly on that BLK page and tracking through the BLK team.
Wonderful. And I can see where it would definitely be useful for the vast majority of crime scene scanning. So you would say that in the future you anticipate that the BLK will be deployed with potentially a survey scanner like the C10, and have the two sets of data combined into one point cloud?
It's absolutely a possibility, and really the possibilities are endless. We're going to have agencies that, just simply will never have the budget to buy a survey grade laser scanner. And that's one of the reasons why the BLK is there. They'll need to know their thresholds, and we engage quite a bit with state level agencies that do have that funding. So in many instances, we see smaller agencies get into some of our I don't want to call them entry level, but I'll say different sensors. I mean, we have GPS that is survey grade. We have total stations that are survey grade. So we have instances in which an agency may buy a survey grade total station and use the state agency that works in their jurisdiction to respond out with a survey grade laser scanner for cases that, you know, dictate that kind of response. So absolutely the data from a BLK can be combined with the survey grade data from one of our survey grade scanners. In that example I was describing about, you know, shooting the basement with the C10 and then, you know, having the BLK for the rest of the house, as awesome as that would have been, we would have joined at the stairway that connected the basement to the upstairs and had that be the joining, you know, the match point for those two data sets. So yes, it's absolutely possible.
Well, that sounds fantastic. I have not seen any questions come across on my screen. I don't know if you want to check your tab and see if anybody has sent anything to you privately. And anybody that, you know, in the future, if you, once we log off of the webinar, if you decide that you want to send a question to Ryan directly, I assume, Ryan, you would be more than happy to accept any questions to the email address that you have posted.
Absolutely. Any questions? You know, follow up, you know, if you need to be pointed towards the landscape study, you know, we've got that posted, all the links to that in our Ready Room on the Leica Public Safety Group page. If anybody wants to see the documentation on the state or the Daubert Challenge to the, you know, to the scanner that we went through in Albuquerque, I'd be happy to provide that. If I am going to provide information about or BLK data, it will probably be in the form of a YouTube video or something like that, but you know, I'll gladly entertain requests for follow-up information. That's certainly a major part of what my responsibility is, and I'm more than happy to do it.
Okay. I do have some questions coming through. Eugene has asked, does Leica recommend that the BLK be used only for demonstrative purposes?
Well, I mean, I've just laid out the difference between an imaging scanner and a survey grade scanner. So if you were hoping to do analysis from a crime scene, whether it be bloodstain patterns, shooting incident reconstruction, crash analysis, if you can't answer the questions about accuracy, if you can't check all the boxes off, then that is a concern. And you know, it's very clearly titled the BLK 360 imaging scanner, so it falls into that non-scientific grade of scanner that I discussed, comparing both survey grade and non-survey grade. So yes.
Okay. And then we have Thomas. He has asked, is Auditors Recap the only software that integrates with the BLK? Will there be other software options in the future?
There are very likely to be you know, different options for accessing the data. You know, I don't want to speak to really anything that the future holds for that, because there is a team that's working BLK aspects very specifically, and that page I mentioned, the autodesk.blk360.com, that is the conduit for that information. There are tabs on there where you can ask questions of the BLK team. I think they're able to discuss a little bit more thoroughly what those options may be. You know, there's a big move towards E57 as far as data universality. I don't know if that's something we're going to see, but asking those questions to that BLK team would be, you know, really, I think, a good way to go.
Okay, that sounds great. I think the only other question, we had a few people that came on a little bit towards the midpoint of your presentation, and just to let those people know, yes, the webinar will be available online later. We will be posting, we recorded the entire thing, including the question and answer session, and all of that will be posted on the IAFSM website. So if you need to log on at a later date to see the portion that you missed, if you came on to the presentation late, you should be able to do that within the next week or so.
And, you know, just as an aside, again, my email address is completely, you know, open. Send me information, send me questions. I'm also on LinkedIn. I'm very active on LinkedIn as far as, you know, posting in groups and kind of being socially conscious of what's happening in the industry. So if anybody wants to link in with me, I'd be more than happy to do that as well. And I do blog posts and things like that on educational aspects of laser scanning and different topics. If anybody has any good information to send me, I'm always welcome. And again, like I said, my involvement in some of those national committees, I'm happy to take that information forward. You know, I'm just really excited to be at the place I am right now. Number one, working in an industry that I've been in love with for years, but you know, really as things are evolving so you know, dramatically in fairly short amounts of time, it's a very exciting thing to be a part of, but also to maintain some connection to my roots as a crime scene investigator. You know, 16 years as an active CSI for 2 different departments. That is a part of my life that I relish and you know, truly love, and I'm glad to be a part of that. So whether it's, you know, any of the things that we've talked about today, please reach out. I'm always happy to engage.
That sounds wonderful, Ryan. Thank you again for joining us. We'll let you know if anybody sends us questions directly, and we'll forward that to you if they don't have your email address written down. But otherwise, we will go ahead and call it for the day. And
well, thank you for the opportunity to the IAFSM and to all those that tuned in live and to those that listen later on. I appreciate you're stopping by to hear the information, and I look forward to working with all of you into the future.
That sounds good. Thank you again, Ryan.